All right, problem number 9. They're constant velocity buggies. We don't have to use SUVOT. We have to use the constant velocity buggy formula. Very exciting. And so we're going to write down the equation for buggy A and the equation for buggy B. So buggy A starts here at the 200 centimeter mark. Another excellent drawing of a buggy. I'm just kidding. It looks like a cockroach with like raisins under it. And this looks like a very sad carrot on top of a couple of olives. So we're at the 200 centimeter mark and we're rolling backwards. That's buggy A. And then buggy B starts at the, it's actually starting at the 40 centimeter mark. How sassy of you, buggy B. My goodness. So buggy A is going backwards at 10 centimeters a second. So that's negative 10 centimeters per second. And buggy B is moving forwards at 20 centimeters a second. So I can actually set up my equation for buggy A very carefully as x of A equals negative 10t plus 200. And buggy B, xb, equals 20t plus 40. Very exciting. All right, now let's use this math to figure out when the buggies meet. I'm just going to tell you right now, we may not get nice numbers for the time. You're not guaranteed whole, nice, neat numbers here. So we're going to see how this works out. I'm actually already seeing not the happiest number. I'm just taking a cursory glance at these correct equations. So let's go ahead and use A and B to determine the time when the buggies meet. So they're going to meet when they actually run into the same place or the same position. So that'll be negative 10t plus 200 should be set equal to 20t plus 40. And so I'm going to actually add 10t to both sides. And continuing here, we're going to end up getting, and you know what? I'm going to actually subtract 40 from both sides as well. So when I work that out, I'm going to actually end up getting 160 equals 30 times t. So when I simplify this, t ends up being about 5.3 seconds. Don't use the repeating sign. It ends up being like 5.3333 forever. Don't use the repeating sign. We don't do that in physics. We don't put that little bar. We'll just take it as 5.3. All right. Now, continuing with this problem, we're going to go ahead and determine the position. So I'll just plug it into either one of these, into the B formula. XB equals, so this is part C, and then XB, so all this is part C. And this is the answer to part C. For part D, I'm going to use the B equation. So I'll say 20 times 5.3 plus 40. And we're going to see where that works out to. And again, this is going to be a bit of an approximation because we rounded. And I'm getting that they meet at about 146 centimeters. I'm just going to do a quick check. You can plug into the other formula just to verify that. So yeah, that looks right. So yeah, about 146, 147 centimeters. All right. Now, on the next page, we have a very exciting graph that we're going to draw. We want to actually determine where these buggies are going to meet. So what I'm going to do is this. Just in order to keep my sanity and not have to flip back and forth between pages, I'm going to take these two equations and I'm going to actually copy them here. And I will move them just a little bit. And I might shrink this screen down just so we can fit it all on one graph and actually see what we're doing. So there we go. Awesome. So let's go ahead and I'm going to see 1, 2, 3, 4, 5, 6 seconds. Alrighty. 1, 2, 3, 4, 5, and 6 seconds. Yeah. And then let's actually, I'm going to go all the way up to the 200 mark on the vertical axis because this is the time axis. And then on the position axis, let's see, so 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. How charming. So 20, 40, 60, 80. So the little squares each represent 10. 100, 120, 140, 160, 180, and 200 centimeters. Meow. Very exciting. Okay, now let's draw the graph for XA. It starts at 200 and it has a slope of 10. So every 1 second, careful, I got to go over 2 to reach 1 second, 2 to the right to reach 1 second. I'm going to go down 10. So over like this, counting squares. I got to be careful what I'm doing here. That's the deal. That's what we signed on to. All right, now let me see if I can actually get this thing to. It never does what I want. And will it? Oh, almost. Dare we hope? It's not going to. Okay. You know what? Maybe I can at least trace it, and that'll give me at least something I can work with. So yeah, there we go. Oh, that was awful. I'm going to really try to draw this line in carefully. It's not going to work out because I don't have like a ruler on this tool. So we have that. Okay. I'll give you rulers on the test. You don't want to sketch it in like this. All right, so there's XA. Now for XB, we start off at the 40 mark, and we're going to go with a slope of 20. So I go over 1 up to 60 here, over 1 second up to 80, over 1 up to 100, over 1 up to 120, 140, over 2 up to 160, like that. And so I can actually kind of fill this in. And what you'll see is, this is not the best drawn graph, but if you actually look at where these lines meet, roughly speaking, we're at about right a little bit before 150 and a little bit after 5.3. So if you actually look here, this is a pretty good approximation. It's about 5.3 and 147. So not the best graphing job, I admit. I really want us to use rulers on the test, and I'll give you rulers. But this really is how we do the last bonus question on the test. So that wraps up our coverage of the practice test. I'll put these solutions on Haiku. It is Friday. It's about half an hour before Haiku's going to go down, so I'm going to actually print this up and put it on there now.